Picture an era before time, before space. Welcome to the realm of the unknown, the pre-Big Bang universe, a sea of infinite energy, a state of singularity, a cosmic mystery, still unraveling in the 24th century. Embark with us as we delve into the profound theory of Sir Roger Penrose, an eminent British physicist. Penrose conceives the universe not as a one-time event, but as an endless cycle of expansion and contraction. Imagine a universe evolving from an ancient cold state to a young hot state. This process is not linear but cyclical, a continuous dance of creation and dissolution. The cold, empty state persists indefinitely in its own time geometry, while the hot, compact state generates its own temporal sequence. This dichotomy helps us understand the cyclical process where the hot, compact state emerges from the cold, empty state, each existing in different time scales. But why does something exist rather than nothing? Three comprehensive options exist for this profound question. First, there might be no physical explanation. Second, cycles may infinitely repeat, each giving birth to a new universe. Third, a singular recurring cycle where its beginning is described by its end. Penrose proposes a sequence of infinite cycles, each distinct due to random quantum events. This theory provides an intriguing opportunity for experimental physicists to observe the ancient universe through residual radiation effects from the Big Bang. However, Penrose's multi-cyclical cosmology could be transformed into a single-cycle state. In this case, the physical reality comprises a single cycle around the Big Bang, extending to an infinitely empty state in the distant future, then reforming around the Big Bang, repeating the same universe. So, as we journey back to the processes before any stable matter existed, Penrose's theory presents us with a cosmic riddle. Did something indeed come from nothing? Or was there always something, hidden in the depths of the cosmic abyss, waiting to ignite the spark that created our universe? Imagine peering into the cosmic abyss, a realm untouched by time and space. What existed before the Big Bang? This fundamental question has intrigued cosmologists for ages. Today we delve into some mind-boggling theories that might just have the answers we seek. The first theory we explore is the concept of nothing comes from nothing. In other words, for something to exist, there has to be a precursor, a component that catalyzes its existence. So, where did the matter that sparked the Big Bang come from? What was the catalyst that ignited this cosmic explosion? Physicist Brian Cox warns of a future where the last star cools and fades into oblivion, plunging the universe back into a void devoid of light, life, and meaning. This chilling vision of the universe's future, strangely enough, might be a glimpse into its past, before the Big Bang. Some cosmologists propose that our universe was born from a cold and dark universe, much like the one we're destined for. In this theory, all matter gets swallowed by supermassive black holes, evaporates and turns into nothing. Space expands until any activity comes to a halt, and from this nothingness, our universe was born. But let's rewind a bit. We need to understand what physical matter is. Atoms and molecules, the building blocks of matter as we know it, didn't exist during the Big Bang or even hundreds of thousands of years after it. It was only when the universe cooled enough that these complex substances became stable. The first particles of matter with long lifetimes, protons and neutrons, formed atomic nuclei, and this happened a mere tenth of a second after the Big Bang. Before this pivotal moment, there was no matter in the true sense of the word. So, as we journey back to the processes before any stable matter existed, we are faced with a cosmic riddle. Did something indeed come from nothing? Or was there always something, hidden in the depths of the cosmic abyss, waiting to ignite the spark that created our universe? As we delve deeper into the cosmic abyss, we encounter the theory of grand unification. We tread into the realm of theoretical physics, for we cannot conduct experiments potent enough to examine the processes of that era. We rely heavily on theories. The first plausible hypothesis is that our physical universe originated from a primordial soup. This term describes the early state of the universe, a short-lived mix of quarks and the building blocks of protons and neutrons. During this era, both matter and antimatter coexisted in nearly equal amounts. Every particle of matter, like quarks, had an antimatter counterpart, a mirror image, differing by only the slightest degree. When matter and antimatter collide, they annihilate each other, giving birth to a continuous cycle of creation and annihilation. However, the question persists: how did these particles come into existence? The quantum field theory suggests that even a vacuum, seemingly devoid of energy, is a hotbed of physical activity in the form of energy fluctuations. These fluctuations can spontaneously generate particles that vanish almost immediately. This might seem more like a mathematical paradox than reality, but we have observed such particles in numerous experiments. In essence, the vacuum of space-time is in constant flux, endlessly creating and destroying particles. Perhaps this suggests that the quantum vacuum, despite its name, is more than just nothing. It might be the something from which our universe sprang into existence. Venturing further, we arrive at a point where the universe was about a second old. We call this the quantum leap. It is here that our universe's story begins to take a fascinating turn. In this moment, a cosmic imbalance occurred, tipping the scales in favor of matter over antimatter. This imbalance, though minute, was enough to ensure that a tiny proportion of matter survived the continuous creation and annihilation cycle. This surviving matter is what makes up all the galaxies, stars, planets, and life that we know today. But how did this imbalance occur? Why did matter triumph over antimatter? These questions remain some of the most significant unanswered mysteries in cosmology. One hypothesis suggests that this cosmic imbalance might be due to CP violation, a phenomenon where the laws of nature exhibit a slight preference for matter over antimatter. Although CP violation has been observed in experiments on Earth, it's not enough to explain the vast amount of matter in the universe. This discrepancy is known as the baryon asymmetry problem. Another theory proposes that our universe might not be alone. Instead, it could be one of many in a multiverse, each with its own laws of physics. Some of these universes might favor antimatter over matter, while others like ours favor matter. As we explore these mysteries, we begin to realize that our understanding of the universe is still in its infancy. The more we discover, the more questions arise. This quest for knowledge is the engine that drives us forward, pushing us to explore the furthest reaches of the cosmos and the deepest recesses of the quantum world. As we stand on the brink of a new era of discovery, one thing is clear. Our journey into the unknown is far from over. Having delved into the quantum leap, we now embark on a journey to understand the cosmic imbalance further, a phenomenon that shaped the universe as we know it. This is Scene 6, Unraveling the Cosmic Imbalance. We find ourselves standing on the precipice of a vast cosmic mystery. Scientists have probed this imbalance with theories and experiments, yet the definitive answer eludes us. The CP violation hypothesis, though intriguing, fails to fully account for the abundance of matter. The theory of the multiverse, while awe-inspiring, remains largely untested, yet these theories represent our relentless quest to make sense of the cosmos. Each hypothesis, each experiment, each observation brings us a step closer to understanding the true nature of our universe. The cosmic imbalance, this preferential treatment of matter over antimatter, is not just a question about the universe's past, it is a question about our existence. Without this imbalance, matter and antimatter would have annihilated each other, leaving a universe devoid of galaxies, stars, planets, and life. This imbalance, this mystery, is why we are here. As we continue to probe the universe, we must remember that our journey is not just about finding answers, it's about asking the right questions. It's about understanding our place in the universe. It's about unraveling the cosmic imbalance. Thank you for joining us on this journey. Stay curious, stay awed, and keep exploring. The universe is waiting.